Hi, welcome to the session of permutation and combination. In this chapter, we'll discuss about permutation and combination. Permutation means arrangement of a things and combination means the selection of the things. Now, let me start from the scratch. Suppose you have to select 11 players to form a cricket team from the 100 candidates. You have 100 players and you have to select the 11 players from it. So the general formula is NCR, which means selecting of R things from the N things. So it means if you write into this form, we have to select from the 100 candidate, we have to select 11 players, that is 100C11. Now here NCR means N factorial upon R factorial into N minus R factorial. N factorial, then this R factorial, then N minus R factorial. This is called the selection. Here it becomes 100 factorial, 11 factorial and 89 factorial. This is the selection. Now we have select. This is way we can select the 100 candidate, 11 candidates from the 100. Now once we have selected the 11 players, now it's important to arrange them into their betting preference. Obviously, we always have a betting preference. First, who will open, and second, who will open. Right? Now, if we have to arrange into the batting order, say we have to name into the arrangement in this form: first, second, third, fourth, fifth. Now there are the numerous way to arrange them. Now 11 players have to arrange. So in arrangement we use NPR. It means arrangement of R things from the N. This is N factorial upon N minus R factorial. Now the difference between the NPR and NCR in selection and arrangement, this is called arrangement. The difference between the selection and arrangement over here is this factor R factorial. Now it means if I have selected it means arrangement is what? First you select it, selection, and then into R factorial. Suppose you have to arrange R person, then into R factorial. Where did R factorial comes from? This is very important to learn. R people, what is the use of R factorial? Suppose you arrived into the room which has, that has R chairs, right? You arrived into the rooms that has R chairs. Now you have the option R chairs arranged in a row. Suppose they had R chairs arranged in a row. Now you have entered into the room. Now how many options available to you? Suppose you have R chairs, you entered into the room. Now options available for you are R, right? Now once you arrived into the room, let me be seated over here. Now for the second person, first person is seated here. Now for second person, the number of options available are, obviously you are seated at the first one place. The option available are remaining options. Remaining seats are R minus 1. Right? Now when the third person arrives. Now this is, let's say, is seated here. Right? Now when third person arrives, two seated are occupied. The option available to third person is R minus 2, and so on. And the last person, let's say 3, then into 2. The last person have only obviously one option, that is 2. Now this R into R minus 1 to R into minus 2 up to 1 is R factorial, and this is called the arrangement. I hope you get how it comes out, right? Now it means we have learned the arrangement into the row. Now what if this arrangement is into the circle? Now think about the same problem. Now what if this arrangement into a circle? Now you entered into the room, and let's say this circle. I know this is not a proper circle, don't worry about it. Now the chairs are available into the circles. Let's say there are R chairs which are arranged in a circular fashion at the equal space, or the chairs are identical. When you arrived into the room and the arrangement is in this form, let's say now you sit at the first chair. Which is the first chair? You cannot determine. This is the first, this is second, this is first, second, third, fourth. Which is the first, which is second? You don't have any option, right? When you arrived into the room, you have the only one option, or you can say this is the one. And when suppose you arrived into the room, you have no options. You cannot say there is a different thing available. All are identical to you. Now for the first person arrived, it's identical for. Now when the second person arrived, suppose the first person is seated over here, right? Now when the second person arrived into the room, it has a choices, because this is arrived. Now he can make the choice. And clockwise or anti-clockwise to this person. Suppose he can make the choice 3 places ahead of this person, or 5 places anti-clockwise to this person. Now he has the choice. And number of choices he have R minus 1. Obviously, similarly, second person have the r minus 2 and so on, 3 into 2 into 1. So here is the answer is r minus 1 factorial. Because the first person does not have any choice, because everything is identical. Wherever he sits, that this become the reference point for the others, right? Now we have the option r minus 1 factorial. So in the circle, there is always be r minus 1 factorial. Now, suppose I say this all are chairs of different colors. All chairs are of different color. Then, if all the chairs are of the different color, then the possibilities are r minus 1 factorial or something other else. If all the chairs are different color, say there are, let's say 7 chairs in the room. If they are of the same color, 7 chairs of same color, then the answer is r minus 1 factorial, that is 6 factorial. If there are the 7 chairs of different color, the answer would be different here. Here the answer is 7 factorial. Now think about it, why it's 7 factorial here? Because again I'm repeating, it's a matter of choices, it's a matter of selection. Now if all the chairs are of the different color, the first person has the choice. Yes, I want to sit at the blue out of the 7 colors. Yes, I want to sit at the red out of the 7 colors. So yeah, very first person has the choices, because he can differentiate all the things and he can make the choice of the r things, or he can make the choices from the 7 different things. So the first person has the 7 choices, right? Second person has the 6 choices, and so on 1, and this is called the 7 factorial. So don't blindly put the r minus 1 factorial in circular fashion. Think about this option. All have the different colors, and it can be also that the first chair is occupied. It says it can be like that all the chairs are arranged into a circular fashion and the first chair is occupied, or the first chair is dirty, no one can sit on the first chair, or the first chair has a ink spot kind of a questions are in the examinations. So obviously there is no such thing like r minus 1 factorial. There is always a r factorial, right? But once you have determined the position, then you have make the choices of the different positions. Now you can make the similar questions like the question of necklace. This is very common. Necklace. Now if there is a necklace of the flowers, suppose there is a necklace of flowers, right? Now how can you make the arrangement of this? Obviously they are in circle, all are the identical, whatever the pieces of, let's say these are pieces of the flowers, all are identical. Now this is r minus 1 factorial upon 2. Now think why it's upon 2. This upon 2 is because it's necklace, because once this necklace, if you turn around this necklace, the figure is same, right? So from the upside or from the bottom side, the view is same. The view is same. Therefore we can say that two view have the same arrangements. So we have to split into 2. That is r minus 1 by 2 factorial. Or in other words, if you want to understand, let be this is red, it has 4. Let's say be red, then let's be yellow, then let's be blue, and let's be green. Now when you fold it, or when we see from the bottom, it becomes green, then yellow, then blue, then red. Things are same, and these two arrangements are same. Therefore we have to divide it by the 2. So necklace, the answer is r minus 1 factorial upon 2. Now again, do not do it blindly. This is the case when you use the balls, you use the same similar things. Suppose I ask you the things which are same at from the top and the bottom also. Suppose if I ask you to make the necklace of the skeleton of the human brain, a human face, don't fear about it. Suppose you have to make the necklace of this skeleton, right? Now it may be identical, but front side and back side are not identical. Here the answer would be r minus 1. If you make the necklace of such kind of things, the answer would be r minus 1 factorial. I hope you understand it. Thank you. Thanks a lot.